So, welcome to our February edition of AWS News. Today we have a couple of standard topics that we consider a bit deeper than usually, and then, as usual, news and new features. Let's start with features. So recently we had one issue with Siemens project. We needed to replicate basically copy all the files from one bucket to another bucket in another account. And so we needed to do it quite like in a couple of hours. But if you do it just with CLI commands, AWS CP minus recursive, blah, 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 it takes a lot of time. So basically it doesn't happen in the background somehow, but it goes through your CLI. So basically, to accelerate the commands, the process, you need to run multiple commands in parallel, and then so basically split your files also in chunks and process each chunk separately in parallel. Then you can accelerate the process. But it's quite obvious that AWS can actually do it by itself somehow in the background and synchronize to destination, source and destination. And just recently, this moment, so we didn't discover it for that case, but it actually came in January, end of January, this AWS S3 replication. It's part of the batch operation. So if you go to S3, you can find this batch operation settings, so where you can basically define some jobs, and replication now is also type of such jobs. Now you define source, destination, click apply, and basically it will be done. Of course, quite efficient and much faster as you would do it with the AWS CLI. Then one another very useful feature that we'll probably try at our Deutsche Bahn project, where we use step functions. Now you can, so in December, I guess, we talked that after or during the reInvent, they announced step functions integration. So basically you can now connect your step functions with different kinds of services. You can also mock your endpoints. Now you can even run it locally. So they provide two possibilities. Either you run it as a Docker image, Docker container, or as a Java jar program. So your endpoints or steps, you can also either mock or redefine endpoints that will be invoked. And basically you can test your logic, because step functions logic might quite often be very, very comprehensive and huge. So for example, our JSON definition is like, I don't know, 3,000 lines or something like that. It's extremely, it's also like core of our data processing. It's very important that all the logic works properly. So we'll definitely try it out. Redshift ingestion from Kinesis. So it was possible to do it previously. So basically Kinesis, as a recap, Kinesis is streaming service from AWS managed service, and Redshift is storage, column storage for analytics. And it's quite obvious that you can ingest data with Kinesis. So for example, you have, I don't know, Internet of Things devices or logs somewhere which constantly produced, and you just need to ingest this data to your data lake or to your analytics database. And now you can just do it directly. You can define in Kinesis, you can define columns for the data, for the streaming data, and you basically need just to map these streams, Kinesis streams, with the Redshift columns, and this ingestion will be done automatically. So pretty nice. One another thing, so I'd like to look at it personally since like long time already, this Code Guru service. So here's about code reviewer, but code review includes also other tools and features. So basically it's a machine learning based engine which can analyze, review your code, help you writing code, suggest, and so on. Plenty of features. And here's just about this last log4j vulnerability. Now you can detect it automatically. So since Code Guru detects that your code probably uses, I don't know, last old versions of log4j or something like that, it will just alert you. Right. So recently we also had a talk with Bayer a label team regarding storage. No, not a label, sorry. It was a simple project. It was like EFS storage didn't work, and we need to figure out if EBS would work for us. So I just was thinking maybe to make this one slide to remind everyone which storage types in general we have at AWS and what the difference, which kind of storage should we use at any particular use case. So here you can see 4 types. There are actually one more. It's ephemeral storage. So whenever you run EC2 instance, you can choose if you attach EBS volume. So basically, it's always an option. It should be attached. But basically, like on the physical level, it has 2 devices, 2 storages, 2 disks. One's ephemeral, so this device is attached to EC2 instance, like very toughly coupled. It's basically located at the same place where the instance, where the virtual machine itself is. But it's ephemeral, right? So whenever you restart your instance, when you stop it, run it again, all the data which is stored on this disk will be deleted. And EBS volume is this persistent storage. But basically the entire data exchange is happening through network. That's why it's not that fast as ephemeral, but you can attach it, you can detach it, you can create images out of it, and it's basically like the core of all the storages, the block storages at Amazon. It's used everywhere. It's also used at RDS. It's used at every service that uses EC2 internally, and so on. EFS, it's Amazon internally developed file system, which is designed for syncing data from different destinations and sources. So let's assume you have 2 EC2 instances, and if you need to keep data synchronized between them, you could use this EFS type of storage. If you don't need this synchronization, it's quite a rare case, I have to say. It's not that like you should use EFS always. It's also quite expensive because it includes like this low-level engine which has to replicate data constantly It's very efficient, it's very well done, but you have to pay for it. So it was about file storages, right? So EBS and EFS, it's file systems. It's important to understand it's file system. So it's basically back compatible with all the operating system file systems. You can use it for storing files, and it will work everywhere with every software. Then we have S3, which is not a file system. It's important to understand. It's just object storage. Object is not a file. It doesn't have this file properties, and it's not. So basically, the nature of object is different from the files in file systems. So Glacier here it's just like another storage type inside of S3. It's not a big difference, so it just uses another physical devices in the background, cheaper devices, so basically last generation devices, which is not that fast as the default ones, but just much cheaper. And whenever your data is not frequently accessed or used, it probably makes sense just to change this storage type inside of S3 to not frequent storage, or to Glacier. That's it to storage types. And we also have one topic today regarding VPC, and Tilman wanted to tell us about it. Tilman, please.
Yes. So, yeah, I guess this part will be rather an introduction and a deep dive, but maybe in a follow-up we can then show you also just setup, for example, in our project. So yeah, this should be just an introduction to VPC, probably more for colleagues who didn't do that much with VPC in AWS yet. So what is a VPC in AWS? Here it is. VPC is basically the abbreviation for Virtual Private Cloud. And yeah, it's basically a structure in AWS which defines logically isolated part of the whole AWS infrastructure where you can deploy your resources in. And with a VPC, what you create, you just have full access control by setting firewall rules, and where you can easily define the routing between the services you deployed in there. VPC has to be located in a certain AWS region, but it can have multiple, and usually will have multiple availability zones in which the subnets, which is basically the substructure of a VPC, are deployed in. And you can see this in the picture on the right. So within one availability zone, there can also be multiple subnets. When you create a VPC, you basically have to define a size, which of course depends on your use case, how many resources you want to deploy in this VPC. And you do this basically by an IP address allocation. If you choose IPv4, you do this by setting a certain CIDR range, which then defines the address space of your subnets and of your VPC. And the size, can vary a lot from 16 to even 60,000 addresses. And of course, in general, you wouldn't use both extremes, as the minimum, for example, is also the minimum allocation for one subnet, and you, in most cases, will never use just one subnet per VPC. There's more subnets where you have deployed certain resources, for example, as read replicas will increase like the availability and also the scalability of your setup. With IPv6, it's a little bit different, and the allocation is done more in the background. And also, if you choose IPv6, basically all your resources will have both an IPv6 address and also an IPv4 address, which is called dual stack mode. So if we look back at the picture before and you have the subnets, you can see that now, in this case, IPv6 was chosen. You have an address range for every subnet, both IPv6 and IPv4, and also one for the whole VPC. Now, if you created a subnet, and we suppose that we also deployed certain resources into this VPC, in most cases, you would somehow want to connect to the internet. And you cannot do this like after you created a VPC, you don't have connection to the internet. So you have to fulfill some requirements to do this. And the first requirement would be that the resources in a subnet with a public IP address, at least for now. And if that's so, you would need to attach an internet gateway to the subnet, as an internet gateway basically allows access to the internet from a virtual private cloud, and you need one in your VPC, otherwise you cannot access the internet. This alone isn't enough, because you basically have to tell how to route traffic to the internet, and it has to be routed via the internet gateway. So you define a route table, or it's also automatically defined already, but you have to alter it to basically tell that traffic to the internet has to go via the internet gateway. So if you look here, we have on the top with a public subnet and a private subnet and their route tables. You can see the first two lines are identical because they more or less tell if the destination is the local subnet. It's local, so you can, all resources within the subnet can access itself or are routed to the subnet. And these two lines, they basically say, like for IPv4 and IPv6, that traffic to the internet is routed to the internet gateway, and like so, access to the internet is possible. So, but what to do if you have resources in a private subnet? How to connect these to the internet? For this, you can use a network address translation gateway. This NAT gateway is deployed in a public subnet, and you have to add this NAT gateway to the route table of the private subnet. And like so, internet access, in this case IPv4 traffic, is then route to the net gateway, and the net gateway itself will basically pretend that this traffic is coming from the net gateway, which is in the public subnet, and as the route table here is set to then route the traffic to the internet gateway, you also have internet access from the private subnet. Yeah, so the last two requirements you basically have to meet then is to set firewall rules. And you basically have two options in AWS to set those rules. One are network access control lists, and the other one are security groups. And network access control lists are basically stateless firewalls. You define one network access list per subnet, only one. And within this NACL, you define inbound and outbound rules to destinations. And these can either be allow or deny rules. So you can specifically allow certain connections or also deny certain connections. Stateless in this regard means that if you have an allowed outbound traffic, for example, the response is not allowed automatically too, but the response is also subject to the rules you set, and also vice versa. And yeah, by default, this NACL will allow all inbound and outbound traffic. And on the contrary to security groups, it has a rule process order. So you basically assign a number to each of these rules, and they're then processed in a certain order. Yeah, security groups. These are basically also firewall. Is basically also a firewall, but on the level of EC2 instances compared to a subnet level for NACLs. And you can also define more than just one security group per EC2 instance. On the contrary, you only set allow rules, and it's also stateful, so that every response to an allowed traffic, if it's outbound or inbound, is allowed automatically. So yeah, the response doesn't depend on the rules you set. The default for security groups is also to allow both all inbound and outbound traffic, and on the contrary to security groups, to NACLs, you don't have process order of these rules, so they're just all applied. Yeah, this was already the short introduction. I thought maybe next time we could have a look at our setup at Bayer, where we have a VPC, and maybe a special use case where we have an RDS instance and a private subnet of the VPC, which has to connect to another VPC of a different team. And yeah, I think this would be a nice way to show how a VPC and all these attachments look like in the real world.
Would be great. Yeah, cool. Thank you, Tilman. I think you're ready now for AWS Solutions Architect certification. After all the presentation, it basically covers all the networking for the exam. Cool. Do you guys have any questions regarding VPC or previous topics today? Or maybe notes.
I will also post a link. There's an awesome 1-hour YouTube video, which is really the best about networking fundamentals. It goes way beyond the introduction. And I also have to admit that most of the pictures are from there. So, yeah.
Yeah, cool. Do it. Just do it. All right. Then, thank you. I'll stop recording.
Thinkport. Cloud Consulting mit Startup Spirit.